In this video, I will continue our discussion on similarity using proportionality theorems. So in section 6.6, we already discussed a couple of theorems, and the next two theorems piggyback on those. So on page 398 of your textbook, theorem 6.6 says, if three parallel lines intersect two transversals, so my parallel lines here are R, S, and T, and I know that because of the triangle. And I have my two transversals, L and M. Then the parallel lines divide the transversals proportionally. So I can set up a proportion and solve for a missing value if I have enough information. So for example, I can take UW, so I'm on the top transversal. If I take that over WY, so left to right, so top, left to right, I need to move left to right again. So that's going to equal Vx over xz. And we, in the first section of this chapter, dealt with a couple of properties that allow us to do, if instead I did UW over Vx, that would equal Wy over xz. So depending on how you want to set it up and where your values are, you can fiddle with those properties. The next theorem we have is theorem 6.7. And this theorem says, if a ray bisects an angle of a triangle, then it divides the opposite side. So here's the angle, angle C that it's dividing. It divides the opposite side into segments whose lengths are proportional to the lengths of the other two sides. So for example here, if I have AD over the other side of the triangle it has created, AC, that is going to equal BD over BC. Alright, and I should be able to fiddle with those properties again, and I could do AD over BD equals AC over BC, and as you can probably predict that I'm going to say consistency is key. Just be careful of how you're moving. If you're moving from one triangle to the other, which side to which side, you just have to be consistent. So let's go ahead and look at a couple of examples and the checkpoints. In example 3 on page 399, we are given this problem. It says, in the diagram, angles 1, 2, and 3, this is angle 1, 2, and 3, are congruent. And we're given a couple of measurements between the streets. So our goal is to find the distance between Main Street and South Main. So Main Street and South Main, it says between points F and H. So I need to find this missing piece before I can verify what the entire distance is. So I need to use the theorem 6.6 and set up a proportion. So I'm going to go ahead and just label this x. Right? So I can do 120 over x equals 150 over 300. And I can do this because I know that these lines, these streets, are parallel because those angles are congruent. Corresponding angles are congruent, causing those streets to be parallel. So I could do 120 over x equals 150 over 300. I could do x over 120 equals 300 over 150, or I could do 120 over 150 equals x over 300. I could keep going and fiddle with a whole bunch of properties here. So I'm just going to go ahead and take this last one. Cross multiply, 150x equals 120 times 300. And when I divide by 150 on each side, I get 240 for this missing length. So to answer my entire question, I need to add 120 plus 240 and get 360. So the value for Main Street to South Main is 360. In this next example, example 4 on page 399, we're going to be using theorem 6.7. So our goal is to find the length of RS. So we want to find the value of x. And we need to be able to set up a proportion using theorem 6.7. So what 6.7 said was that if I have an angle bisector, which I do, and it cuts the opposite side into proportional pieces. So I could have RQ over PQ, RQ over PQ, and that would equal RS over PS. So I can write that out with the sides and then actually fill in the values. So I'm going to start on the right side. I know that RS is X and PS is 13. Okay, I don't, however, know what RQ is. RQ, if I look at the entire length of QS, here's QS, that is 15, and then here to R is X. So I can take 15 minus X, and that's about as good as I can get for now. I don't know what it is, but I know that it's 15 minus the value of RS. And take that over PQ, which is 7. When I cross multiply here, I get 7x equals, and I have to distribute that 13 and get 195 minus 13x. And then I need to add my like terms and get 20x equals 195 and x equals 9.75. If you want a little bit of practice, I'm going to draw guided practice 3 and 4, and then just pause it for a couple of seconds, pause the video, and the solutions with work will pop onto your screen. Okay, so the work is presented on your screen. I do want to talk about number 4. So real quick, it is a 45, 45, 90 isosceles right triangle. So that means since these two are equal, it does, well, because these sides are equal, I know that the angles are congruent and it is split exactly in half, so that makes them both 45. And because of that, I know that these opposite legs should be equal. So technically, you don't even really need to show any of this work if you knew all of that. Alright, if you guys have questions, feel free to email me or see me before or after school. Your assignment is as follows. Page 400, 8 through 12, 14 and 15, and 17 and 18. Please show all of your work, even for multiple choice questions, and for the error analysis questions, try to describe where they went wrong.